Hello everyone, welcome to free crash course for competitive exams held by VIRAT Hindustan Sangham in association with Manifest IAS Bengaluru. This program is inspired by Dr. SUBRAMANIAN SWAMY and is convened by Sri RAVISHANKar, State Education Convener for VHS Karnataka and also President of Good Neighbors India NGO. So I'm the chief mentor of your program. So we're done with polity, history and economy and negotiating the geography part of your syllabus. And you can watch this program online on the YouTube channel of VIRAT Hindustan Sangham. If you go view YouTube on it's a YouTube channel on the VIRAT Hindustan Sangham where it will be telecasted regularly. And for further any doubts, queries, you can join our Telegram channel VHS Education Forum. So for any mentoring guidance regarding any competitive exams, you can join our Telegram channel. Okay. So last week we were discussing the atmospheric circulation and weather systems. So how does the circulation takes place in the atmosphere? What is the pressure variation? What is temperature variation? So how does the pressure vary vertically and horizontally? All these were the basic concepts discussed in the last class. So now we should look at the world distribution of the pressure. Sea level at the pressure at the sea level. See, pressure is always measured at the sea level. So when the pressure is measured at the sea level, what is the world distribution? How is it distributed across the world? So that we should know. So here, here we have distribution of pressure in January. How is the pressure distributed in the January part? So in January, what happens? The sun will be in the southern hemisphere. So moving from southern hemisphere towards northern hemisphere. So what happens? The ITCZ. So ITCZ in the January. So it will be below here, right? So ITCZ means what? Intertropical convergence zone. What is intertropical convergence zone? So here, what happens? For this, I need to explain one more concept. Yes. So this is the ITCZ. So here ITCZ means where the sun rays of the sun directly fall on the earth. So on which latitude does the rays of the sun vertically fall on the earth. So generally in the summer that is around June 22nd, what happens? The sun rays will be falling vertically on the Tropic of Cancer. So ITCZ will be moving towards the Tropic of Cancer in the month of June. Whereas in the month of December, what happens? The ITCZ, Intertropical Convergence Zone, it moves towards the Tropic of Cancer. Tropic of Cancer in the southern hemisphere, that is in the month of December. Whereas in the month of March as well as in the month of September, it will be on the equator. It will be exactly on the equator. So this is at that time is called as equinox. Means the days and nights are equal. Days and nights will be equal on in the month of March, one day around September, March 22nd or 23rd, and also in the month of September, there will be equal days and nights, right? So this is how where the sun rays fall exactly on the surface of the earth, that is called as ITCZ. This is see, equator won't be moving. Equator will be static at the same level, whereas ITCZ would be moving. So because why does the ITCZ move? Because earth is tilted, right? So earth is tilted like this, 66.5 degree to the plane of the revolution, 66.5 degree. So because earth is tilted, what happens? So the sun rays won't be falling exactly on the equator. It won't be falling exactly on the equator. Rather, as the earth rotates and revolves around the sun in a particular orbit, the sun rays will be moving from 0 degree up to 30 degree north or up to 23.5 degree, that is Tropic of Cancer, and also from 0 degree up to 23.5 degrees south, that is Tropic of Cancer. So wherever the sun moves, actually it is not the sun which is moving, it is earth which is revolving and rotating. Because of that, it appears to us that sun is moving over the between the Tropic of Cancer and Tropic of Capricorn. Wherever the sun rays falls exactly is the zone of ITCZ, Intertropical Convergence Zone. So it also has a concept of what? Concept of pressure variation. We will discuss that. So in the month of January, how is the pressure distributed? In the month of December, so ITCZ is in the northern, it is both above and below the equator, right? So here it is, since it is moving towards the north, from the south it is moving towards the north. See the pressure, these are the pressure variations. So it is high in the sea level, so it is high here, here, and also high over the land level. So in the sea level the pressure will be high in the southern hemisphere during the month of January, and in the northern hemisphere on the land the pressure will be higher. Why pressure will be higher on the land? Because here it will be still what? Still winter. So since it is winter in the northern hemisphere, what happens? It will be when there is winter, what happens? The pressure will be less. So there won't be any heating. Sun rays will be less in the winter. When sun rays are less in the winter, the air is not heated up. The land is not heated up. When the land is not heated up, what happens? It will be cool. When there is cool temperature, there will be lot of pressure. So that is why in the land areas, the pressure will be higher in the northern hemisphere. Whereas see in the southern hemisphere, the oceans are having high pressure. Why oceans are having high pressure? Because here land would have heated up in the summer. Land would have heated up in the summer in the December, January month. Whereas sea wouldn't have heated faster. Sea takes a lot of time to heat up compared to land. So comparatively, compared to the land, pressure will be higher on the sea level during the month of January. So this is how, these are the isobars, the lines of equal pressure across the world. Right? So in the month of July, it will be what? It will be summer in the northern hemisphere and winter in the southern hemisphere. See here, on the land, the pressure is low. Why? Because it is summer, the land gets heated up. When the land gets heated up, the air will rise up. When the air rises up, what happens? The pressure will become low. So that's why in the northern hemisphere, the pressure will be lower on the land. Whereas on the, here also it will be lower. Whereas on the sea, in the sea level, what happens? The sea wouldn't heat up as fast as the land. So on the sea level, the pressure will be very high. Pressure will be high. On the land, it will be lower. Whereas see here, in the southern hemisphere, since it is winter, it is both, the pressure is high on both land and sea. So it is higher, and the isobars are almost parallel, almost parallel across the world. Okay. So this is the concept of the world distribution of the sea level pressure in the month of June and in the month of July and January. Next, here, first we should understand this ITCZ, why the 0 degree is called as a equatorial low, because the pressure at the 0 degree, pressure at the equator will be very low. Why? Because the sun rays will be falling directly. So most of the time sun rays will be falling on the 0 degree, or it will be moving upper or lower. So that is why at the 0 degree, that is at the equator, the pressure will be lower. Why? Because when the sun rays falls there, the air, land and ocean gets heated up, the air above gets heated up. When the air gets heated up, it moves up. When it moves up, the pressure will be very lower. So 0 degree, the pressure will be lower. It is called as equatorial low. The low pressure at the equator is called as equatorial low. Okay. So at the 30 degree and 30 degree north and 30 degree south. So just above the Tropic of Cancer. Where is Tropic of Cancer? See, 23 degree and a half and 23 degree and a half north and south. Okay. So at just above the Tropic of Cancer and Capricorn, at the level of 30 degree north and 30 degree south, the belts are called as subtropical high. Subtropical high. Why it is called subtropical high? Because here the air will the air won't be going up, rather it will be going down. So the pressure will be very high at 30° north and 30° south. So when the pressure is higher, what happens? The air will be subsidizing. Subsidizing means, see, in the equator, when at the equator level, when the land get heated up, the air get heated up and it goes up. So the pressure will be very less. Whereas at the 30°, the pressure will be high. It means what? The air will won't rise up, rather it comes down. It comes down to the surface level. That is why it is called as subtropical high at both 30° north and 30° south level. And also at the 60° north, 60° north and 60° south is called as subpolar low. Means what? Here also the air will rise up. At the 60° north and south, the air will be rising up. It won't subsidize. So at the 60° north and south, I'll explain why does it rise. Right? At the poles, here at the polar level, it is high pressure. Polar level, it is high pressure. Right? So why does the air rise? So you know that, see, let us say that this is equator. Okay. So here the air is rising up due to heating up of the sun. When the air is rising up, what happens? It should move away, right? When it goes up to the troposphere, tropopause, it should move away from the upper atmosphere. This is upper atmosphere, this is lower atmosphere. So when it reaches the upper atmosphere, it should diverge. So it will go this side and it will go this side, right? It reaches up to 30° north and 30° south. And by the time it goes up to 30° north and 30° south, it will cool down. So here it will be heated up, that's why it rose up, and by the time it reaches these latitudes, it will cool down and it will subsidize. It will come down. So when it comes down, what happens? See, here it is rising, that's why pressure will be higher. So when it is coming down, the pressure will be more. So that is why this is at 30° north and south, it is called as subtropical high. Subtropical high. Okay. So when it comes down, what happens? Either it should move this side or it should move this side. Okay. So when it moves this side, it reaches up to 60° north and 60° south. So when it goes up to 60° north and 60° south, so here you should observe one more line, the line of poles, north pole and south pole. So here what happens, at the north pole and the south pole, the pressure will be very high because it is very cool. There is no heating up of the air. When there is no heating up of the air, the pressure will be, the air will be subsidizing. Subsidizing means from the upper atmosphere till the lower atmosphere, there is lot of pressure. When there is lot of pressure, the air will be subsidizing and it comes down to the surface from the upper atmosphere. So when it comes down, what happens? It cannot go this way because this is the tip of the earth, northernmost tip. So it must move this way. So at the surface level, it moves towards the 60° north latitude. See, here it is cold air. Cold air, by the time it reaches 60° north latitude, it becomes warm. Cold air becomes warm because 60° is more warmer than the northern pole. Once it comes to 60° north, and here also from the subtropical low, 30° north, the air is moving towards 60° north. So these two will come here, they will clash, and when they clash, they don't have any other way to go, say they will rise up. So that is why this is called as subpolar low. Same thing happens here also. That is why this is called as subpolar low. And here also it rises up. When it rises up, what happens? It doesn't have any other way to go. So one stream goes this way and other stream goes this way, and the cycle continues. So this is the concept of the equators, equatorial low, subtropical high, subpolar low and tropopolar high, right? So this pressure belt, so these are called as pressure belts. These pressure belts, this pressure, see this from the 0° up to the 30° north, whatever I told, this 0° up to 30° north and 30° south. So whatever I told, it is called as Hadley cell. 0° to 30° north and south is called as Hadley cell, and the from 30 degree north to 60 degree north and 30 degree south to 60 degree south. It is called as ferrule cell, right? So, and 60 degree north to polar north pole and 60 degree south to south pole. So this is called as polar cell. So Hadley cell, ferrule cell and polar cell. These three cells are very important, very important concept, right? Okay. So this pressure belt, these belts, they move with the sun. Why? Because I told you ITCZ, intertropical convergence zone. So let me explain the convergence zones here itself. See here, why this it is called as ITCZ? Because I told you where the sun rays exactly fall on the earth vertically, that is where the ITCZ lies, intertropical convergence zones. Also, there is one more concept. See, the air is converging, right? Air is converging from northern hemisphere and air is converging from the southern hemisphere at the point where the sun rays fall vertically on the earth. So that is why the convergence of the air is also called as is also the reason for that latitude being called as a intertropical convergence zone. Intertropical convergence zone, right? So this pressure belt, it may be the subtropical high, or the subtropical low, or the polar high, or the subpolar low, or the equatorial low. This keeps moving. It is not stationary. So why does it move? Because the sun moves from Tropic of Cancer to Tropic of Capricorn, and it also gets reversed. So this is because of the movement of the sun, the pressure belts also gets moving, right? What are the forces affecting the velocity and direction of the wind? Next is the concept of what forces affect the direction, velocity and the direction of the wind. So the wind moves from high pressure to low pressure areas. That is the first force. So see here, from high pressure to low pressure area, the wind is moving. That is called as, the movement of the wind is called as northeastern trade winds. Whereas, okay. ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? ಕಾಣುತ್ತಾ? ಓಕೆ. Okay. So here from the 30 degree north and 30 degree south, the wind is moving towards the 0 degree. So that is called as northeastern trade winds. So the wind from the subtropical high, I told you, wind moves from the high pressure to low pressure. From the high pressure region of the 30 degree north and south, it is moving towards the low pressure region of the 0 degree. So this is called as the what? Wind. So here it is, this wind here in the northern hemisphere is called northeastern trade. That is why it is called northeastern trade. See, it is coming from the northeast direction. If this is north, this is northeast. So it is coming from the northeast region. So that is why this is northeast trade wind. Whereas here it is moving from southeast. If this is south, so this part is the southeast. So the wind is moving from the 30 degree south to ITCZ 0 degree. So it is called as southeast trade wind. So this is the concept. Wind moves from high pressure to low pressure. And also the second factor affecting the movement of the sun is the movement of the wind is the friction. What the friction encountered at the surface level is the second factor. The third factor that affects the movement of the wind is the Coriolis force. So I have told you what is Coriolis force. So it is a force because of the rotation of the earth. So since the earth rotates, the wind moves in the clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere. So this is the Coriolis force, right? So there are three forces. So I told you at the surface level, the friction is the force. So there are three other forces at the surface level for the wind or the pressure to change. So what are the three forces affecting the wind. One is the pressure gradient force. What is pressure gradient force? So rate of change of pressure with distance. So how much the pressure changes with distance. So let us say this is one point A and point B. How much millibar is the pressure here and how much millibar is the pressure here. So the rate of change of pressure from this point to this point is called as pressure gradient force. So this is the first force of the affecting the movement of wind, pressure gradient force. Suppose this is high pressure, this is low pressure, it will move from this point to this point, right? And also this pressure gradient force. So I told you isobars are the lines which go through the areas of same pressure, right? So if the pressure gradient force is high, what happens? The isobars will be very close. This is a very important concept, because isobar is a line measuring areas of similar pressure. So when the pressure gradient force is high, means the isobars will be close to each other. Whereas when the pressure gradient force is low, means the isobar lines are actually farther from each other. So it will be farther from each other. So pressure gradient force high, isobars will be close. Pressure gradient force low, isobars will be very farther away. So why it is? Because see, when it is high, means when the pressure is changing at a very fast rate. From this point up to this point itself, the pressure changes from at a very close place. So that is why isobars are close. Whereas when the pressure gradient force is low, means the rate of change of pressure is low. When it is low, means the pressure has to take a long distance in order to change. That is why it will be farther away, right? Okay. So also the pressure gradient force is impacted by heat. It is also impacted by the heat. With heat, the pressure gradient changes, forces change, right? So then there is a frictional force at the surface level. The second force is the frictional force. How the when the wind moves, it encounters the friction of the surface, right? So that is the second force. And the third force is the Coriolis force. These are the three forces, and there is one more force, that is the gravitation force. Gravitation force acts downward. Gravitation force acts downwards, whereas the Coriolis force and what is the other force? Pressure gradient force, Coriolis force and frictional force. They act at the surface. Gravitational force acts downwards, right? So then first we will look at the Coriolis force. So what is Coriolis force? Andre, wind gets deflected to right in the northern hemisphere. So if this is Earth, this is equator, the wind will get move towards the clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere. So this is the concept of the Coriolis force. So if there is more deflection, means, so when there are velocity, see, when will the Coriolis force be high? So when does see, if the bending is more, when the bending is more, the Coriolis force is said to be high. When the bending is less, the Coriolis force is said to be less. So if it bends very much like this, so Coriolis force is high. If it bends just like this, so the Coriolis force is low. So why does this change in the Coriolis force takes place? Because of the velocity. If there is high velocity, Coriolis force will be high, the bending will be high. If there is low velocity, the Coriolis force will be low and the bending will be lower. Also, the Coriolis force is proportional to the angle of the latitude. Means what? At the equator level, the bending will be low. Bending will be low, so Coriolis force will be very less at the equator level. Whereas it is high, the bending will be very high at the polar level, at the poles. So Coriolis force will be actually very high at the polar level and very minimal, almost zero at the equator level. just above the equator, the bending starts. Whereas at the equator, the bending will be very low, right? So this is the concept of the Coriolis force. So what is the relationship between the Coriolis force, pressure gradient force, and the isobars? So Coriolis force is actually perpendicular to pressure gradient force, which is perpendicular to isobars. Means I told you isobars are the line connecting areas of similar pressure. Pressure gradient force is the rate of change of pressure with time or with distance, and Coriolis force is the bending of the direction of the wind because of the rotation of the earth. So this force acts perpendicularly to this force, and this acts perpendicular to isobar. That means if pressure gradient force is in this direction, the isobar will be in this direction, and the Coriolis force will be either in this direction or this direction. So each one of them are perpendicular to each other. See, if this is Coriolis force, this is perpendicular to pressure gradient force. So this pressure gradient force is perpendicular to isobar. So isobar should be either in this direction or in the direction of the Coriolis force. So this is the direction among the relationship among the three forces. So when the pressure gradient force, this force is higher. When the pressure gradient force high ittu andre, what happens? The velocity will be more. See, pressure gradient force high means what? There is a very high pressure region and also very low pressure region. Both the regions are present. Both these regions are present, and the wind is moving from the high pressure region to the low pressure regions. So what happens? If the pressure difference between the two regions is very high, the velocity will be more. Means wind will move very fast. Whereas if the pressure gradient force is low, the wind will move very less, right? So if the pressure gradient force is high, what happens? The deflection will also be high. Deflection means the changing. That is the change of direction. Change of direction will also be high. Suppose here is the high pressure region and here is the low pressure region. So if the difference is high, the bending will be very more. If the difference is low, the bending will be very less. So this is the difference between this is the relationship with the velocity and direction of the wind with respect to the pressure gradient force. Right? So this Coriolis force, pressure gradient force, and isobars, these are the forces which determine the velocity and the deflection of the wind, right? So at the equator, what happens? I told you at the equator it will be low pressure area. When there is low pressure area at the equator, the low pressure gets filled because of the, see what happens at the, let's say here is the equator, it is low pressure, right? And it gets filled of the wind, winds blown. So at the subtropical high, and that is 30° north and 30° south, the winds will be moving towards the equator. So here I told you there is no Coriolis force because there is low pressure, and when there is low pressure from the 30° north and 30° south, the air will come and fill this space. So when if there is absence of air and if there is low pressure, when there is low pressure, here it is high pressure, and the winds will move towards the low pressure and fill up that space. When the space is filled up, so the wind will come here and move towards the upper atmosphere from the lower atmosphere, right? So that is why since at the equator there is low pressure and the area gets filled up by the air from the northern hemisphere and southern hemisphere, you don't find cyclones. So cyclones are not found at the equator because the air gets filled up. The Kali space, that is the empty space at the equator or the low pressure zone at the equator, gets filled up. That is why there is absence of cyclones at the equator. You find cyclones either above the equator or below the equator, but not at the equator. Right? Okay, so see, if there is a, I told you, if the Coriolis force and pressure gradient force, if the Coriolis force and the pressure gradient force are perpendicular to each other, if they are perpendicular to each other, what happens? They blow around a low pressure area, right? Coriolis force is the changing force. This is that is the due to the rotation of the earth, and this is due to the change of pressure. If these forces are acting perpendicular to each other, it will lead to formation of cyclones. Cyclones are formed because of when these forces are perpendicular to each other around a low pressure area. Cyclones are always formed around the low pressure areas, right? Okay, so next is the pressure and wind. How the pressure affects the wind, right? So pressure affects the wind. First is the velocity. I told you, because of the change of the pressure, the velocity will change, and also pressure will affect the wind's direction. It affects the wind's velocity as well as the direction, right? So I told you, at the surface level, there is what? There is a frictional force, whereas at the upper atmosphere, there is no frictional force. At the upper atmosphere, you have only Coriolis force and pressure gradient force, whereas no frictional force. Frictional force is only at the surface level. Okay, so the next is the concept of geostropical wind. Geostropic wind. What is geostropic wind? So when the isobars are straight, so isobars are straight like this. Isobars are lines collecting the equal pressure areas. If the isobars are across the latitudes, if they are straight, what happens? The wind will move straight. So it moves straight from one region to other region. So this, when does this happen? This happens when the pressure gradient force is balanced by the Coriolis force. When the Coriolis force is balanced by the pressure gradient force, the isobars, at that situation, the isobars will be parallel to each other. So if it is not parallel, what happens? It will be either like this, because of the change, different areas of different pressure, right? So if they are parallel, what happens? The wind moves straight from one isobar to the other isobar. This movement of straight wind is called as what? The geostropic wind. The movement of wind in a straight direction because of the straight isobars across the latitude is called as geostropical wind. That is, it moves in a straight direction, right? So next we will discuss the concept of cyclones and anticyclones. So these cyclones are always formed around a low pressure area, right? Cyclones are formed around a low pressure area, right? So if there is a low pressure area, there will be cyclone, right? Cyclone will be formed around a low pressure area. If there is a high pressure area, there will be an anticyclone. So anticyclones are always formed around high pressure area, and the cyclones are always formed around the low pressure area, right? Okay, so this also the low level. So with respect to the cyclone, you should understand the pressure is low, whereas the direction of the cyclones in the northern hemisphere. What is the direction of the cyclone in the northern hemisphere? It is actually anti-clockwise. The direction of the cyclone in the northern hemisphere is anti-clockwise. In the southern hemisphere, the direction of the cyclone is clockwise, right? Whereas in the when it comes to anticyclone, this is anticyclone. So when it is, if you look at the anticyclone which blows around a high pressure area, so when you talk about the anticyclone, the direction of anticyclone in the northern hemisphere is clockwise. It is exactly the opposite of the cyclone. So anticyclone, it is clockwise in the northern direction and anti-clockwise in the southern southern hemisphere. So this is very, very important. Cyclones are anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere, whereas anticyclones are clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. This is very, very important, right? Next, the pressure, the circulation at the lower level and higher level are interlinked. So what is the air circulation at the upper atmosphere and lower atmosphere are interlinked? Means what? It is this concept. That is, the air which moves at the upper atmosphere, it is bound to come to the lower atmosphere, and the air which is moving at the southern atmosphere, the lower atmosphere, bound to go to the upper atmosphere. This is called as the air circulation. The upper air circulation and the lower air circulation are interlinked. So this is the concept of the air circulation system, right? That is why I told you, at the low pressure the air will converge and rise, and the high pressure the air will converge here and subside. They will come down, right? So here they will subside and diverge. Sorry, here subtropical high, they will subside and diverge towards this direction and this direction, whereas here it rises and here it converges and rises. So at the low pressure level it will converge and rise. At the high pressure level they will subside and diverge. At the surface level, this is very, very important, right? Next, you have the concept of general circulation of atmosphere. General circulation of atmosphere. So first we have, that is, how does the wind or the air move in the atmosphere? This is called as general circulation. So first we have the it means the movement of the planetary winds. What do you mean by planetary winds? The winds which move across the planet, right? So those are the planetary winds. So we have many types of winds. So on what factors does the wind, or what is wind? Wind is the movement of air. On what factors does the movement of wind depends upon, right? So the first is the latitudes. That is the lines, horizontal lines. Based on that the planetary winds will be dependent upon, right? See why it depends on the latitude? Because each latitude has different temperature. So when there is different temperature, the pressure will be different. That is why the circulation will be different. Also, pressure belts, high pressure belt, low pressure belt, whatever I discuss, based on that also the movement of the wind will be affected. Not only that, sun movement, I told you ITCZ. So with the movement of the sun also, the pressure belts or the movement of the wind will be affected. Next is continental and ocean distribution. So definitely the movement of the wind will be affected by the continents and oceans, how they are distributed. So this wind might be moving in the ocean. So you take the example of monsoon, it moves over the ocean, Indian Ocean, suddenly it hits the Western Ghats, right? Western Ghats. So it will rise up the Western Ghats, right? So the movement of the wind is also affected by the distribution of the continents and ocean, and also it is affected by the rotation of the earth. How is it affected by the rotation of the earth? The Coriolis force, because of the Coriolis force. So I told you ITCZ. So ITCZ, the definition is at the ITCZ, how does the air rise? So I told you 5 concepts based on which the movement of the wind is affected, right? These concepts are very, very important. And the general circulation of atmosphere, when it comes to general circulation of atmosphere, the concept of ITCZ is very, very important. So how does the ITCZ work? So ITCZ, I told you the sun rays will be falling directly on the ITCZ. So if this is ITCZ, here because of excess heating up, what happens? Air rises by convection. Convection means the land gets heated up, the land heats the surface area, the air above the surface, and the air will rise up. So this is the concept of air rising by convection. So why does it rise? Because of the excess heat at the ITCZ, and also low pressure, the air rises up, right? Okay. So this is the, I shown you the ITCZ. So this is the ITCZ where the air rises up because of the excess heat of the sun and also low pressure. So here at the 30° north and south, the air will cool down and sink, and also here the because of the pressure variation in the pressure, what happens, there are easterlies. So these northeast trade winds are called as easterlies. Why is it called easterlies? Because they move from the east direction. The air that is moving from the eastern direction are called as easterlies. See, the naming of the air or the wind is always from the direction which it flows. If it is flowing from north, it is called as northerly. If it is moving from east, it is called as easterly, right? So easterlies, they converge at the ITCZ. So here they will go down, flow at the surface level. Here at the ITCZ, they will converge, right? The easterlies will converge. So, okay. So this entire concept have discussed. So here between the 30° north and 60° north, there is the wind. Because of the change of the pressure, a wind is blowing from the west, that is called as westerly. Wind moving from the western direction in between 30° north and 60° north is called as westerlies. So I have discussed about the Ferrel cell, Hadley cell and polar cell, how the air subsidizes at the high pressure and rises at the low pressure level. So here also, see, northern pole and southern pole, we have just like the northeast trade and southeast trade, we have polar easterlies. Polar easterlies, they move from the east direction. So here also polar easterlies there. Here also polar easterlies are there. At the above the 60° north and 60° and below the 60° south, we have the polar easterlies, right? Okay. So because of this, see what happens, here it is very cold region. Both these poles are of very cold region. Because here it gets heated up, because of these cells, Ferrel cell, Hadley cell and polar cell, the heat get redistributed from the center towards the pole. So it is getting heated here. From here, the heat is moving towards the pole because of this redistribution. Okay. Okay. So this distribution of the heat, it also not only affects the land, it also affects the oceans. So how does it affect the oceans? The oceanic currents, the cold current and the warm current are also affected because of the movement of the wind. How? Because with the pressure change, the wind moves, and when the wind moves, along with it, it moves the oceanic currents. Ocean current will also move along the wind. So the pressure change not only moves the air, it also moves the ocean water in the form of the currents, right? So here one concept is very, very important with respect to the currents. So in the, the Pacific Ocean. So in the Pacific Ocean, what happens? So here this is, you have South America and North America. This is Pacific Ocean, and here you have China, and here you have Australia. So in the Pacific Ocean, there will be warm current. Warm ocean current. Ocean water will be warmer, right? So here, but here you have this, in the South America, you have Peru current. Peru current will be always flowing from, I will discuss what are the currents and what are the cold currents, warm currents, in which direction they flow. So cold, for now you just remember, cold currents always move from the poles towards the equator, and the warm currents always move from the equator towards the pole, right? So in the South America, on the west coast, you have Peru current which is moving from the poles towards the equator. So what happens here, in the Pacific Ocean, the water gets warmed up. When it gets warmed up, it moves towards South America and it replaces the Peru current. It replaces the Peru current. When it replaces the Peru current, what happens? This phenomena, here this warm current will flow towards India. So this phenomena is called as El Nino. El Nino, this is very, very important. El Nino, it just means that warm current from the Pacific Ocean replacing the cold Peruvian current. This phenomena is called as El Nino, and this affects the monsoons in India. Whether there is drought or excess rainfall in India depends on the circulation in the Pacific Ocean. This is called as a El Nino concept. So also there is one more concept called Southern Oscillation. What is Southern Oscillation? See, this is Australia and this is South America. The pressure difference between Australia and South America is called as Southern Oscillation. So when there is, let's say if this is high pressure and this is low pressure, what happens? The wind moves from high pressure to low pressure. When it moves from high pressure to low pressure, it also carries the ocean water along with it. So this is called as Southern Oscillation. So this total concept, El Nino plus Southern Oscillation, this is called as ENSO, E-N-S-O. El Nino plus Southern Oscillation. Southern Oscillation just means the pressure variation in the Pacific Ocean. So this entire thing is called as ENSO. This will affect the monsoons in the India. It affects the monsoon, right? Next, this is the planetary wind, general circulation of the planetary winds. That winds that moves across the planet. We have polar easterlies, we have northeast trade wind, southeast trade wind, we have the westerlies. These are the planetary winds. Now we will move towards the seasonal wind. So what is seasonal wind? So seasonal wind means it comes in seasons, right? Monsoon is the best example. It comes in the season of from the June till towards September, October, the monsoon comes, right? So it is a seasonal wind because of the seasonal modification, summer, winter, rainy season, autumn. Because of this, these winds come. So why does it happen? Because of the shift of regions of maximum heat. Means what? The region of maximum, see, you take the example of the India itself. So it is the maximum heat over India. Maximum heat over India is witnessed only in the summer region, summer times, right? So this maximum heat region keeps moving, right? In the summer it comes and in the winter it goes off. Similarly, if you take the world itself, entire world itself, so the maximum heat region in the June time it will be over Tropic of Cancer. In the December time it will be over Tropic of Capricorn. So the maximum heat region will be moving along. When the heat region keeps moving, the pressure will also keeps moving. So this gives rise to what? It gives rise to wind belts. Wind will move from high pressure to low pressure, the low temperature to high temperature region, right? So this gives rise to wind belts. This is the reason for seasonal winds. That is the change of heat and pressure. These are the reasons for seasonal winds. The best example is your monsoon winds, right? Next you have the concept of local winds. Local winds means the wind which move in the local areas. So what are the local winds? You have the, why does it flow? Because of the Earth's surface heating and cooling. So some of the surface. So on the surface, this region is heated up, this region is cold. So on the surface, so this is actually planetary wind. I am talking about the local wind. So area A has high pressure, area B has low pressure. The wind moves from A to B. This is a local wind, right? So at the local area, right? Next you have the land and sea breezes. This is very important. So what is land and sea breeze? So what happens is the land will see, whenever there is a sunlight, land gets heated up fast, whereas the ocean gets heated up slow during the daytime. So what happens? During the daytime, land will be hotter and seas will be cooler. When this is hotter, this is a region of low pressure and this is a region of high pressure. So as I already told you, the wind moves from high pressure to low pressure. This is called as sea breeze, right? You take the night time. during the night time, what happens? The land gets cooled faster, whereas due to daytime's heat, the sea will cool down slower, so it will be hotter. It is actually the reverse of direction. So at the night, sea will be hotter and land will be cooler, because of which what happens here, when it is cool means the pressure will be higher. When there is pressure is higher, the wind moves from high pressure to low pressure. This is called as land breeze. So the wind moving from land towards the sea is called land breeze, and the wind moving from sea towards the land is called as sea breeze. This happens during the daytime, this happens during the night time. If you go and stand in front of a beach, so you will get air just at hitting at your face. That is the sea breeze, right? Okay, when you are standing at the night, you will get the air, you will feel a push from backside, from the land. That is land breeze, right? So this is also because, see, this pressure difference is the pressure gradient force. This is the pressure gradient force, because of which the air keeps moving between the land and sea. Next you have mountain and valley winds. So at the mountain, so winds in these, this is a valley, this is the tip of mountain. So what are the winds in the mountain and valleys? So during the daytime what happens? The air gets heated up. The air here gets heated up. So when it gets heated up, what happens? It moves up the slope. Hot air moves up the slope, right? This is called as what? Air getting heated up, and it moves upslope. It moves upslope. What happens when the lighter air moves upslope? The colder air will come down. In order to see, when air here, because of heating, moves up, what happens? Here there will be vacuum. When there is vacuum, what happens? Here the air will be cooler because of the altitude. Top areas will have very cold climate, thereby high pressure, and the cold air or the high pressure air will move from the tip of the mountain towards the valley. So this is called as what? Valley breeze. The air coming from top to bottom is called as valley breeze. During the night time, this is during the daytime. During the night time, what happens? Here the air will be cooler, right? So during the night time, here the air would have, at the tip of the mountain, the air would have got cooler. When the air is cooler, what happens? It will be denser. Cool air will always have high pressure, thereby density will be higher. So when the density is higher, what happens? It moves down the slope. This is called as mountain wind. So this air during the daytime moving from the bottom of the valley to the top of the mountain is called as valley breeze. The air moving from valley towards the mountain. Whereas during the night, the hot cold air coming from top to bottom is called as mountain breeze, right? The concept of valley breeze and mountain breeze. Also, there is one more concept, not only in the mountains and valleys, but in high plateaus. So plateaus like Karnataka plateau. So this is not a mountain, but a plateau. Plateau means what? Flat land, table land. So table land situated at a height. It is not at a sea level, but it is located at a height. So the air coming from high plateau towards the mean sea level, or towards the sea level. So this is a plateau. This is sea. So Karnataka also is it is located on a plateau. So the air coming from top of the plateau towards the sea is called as katabatic wind. Towards the sea level, not sea, towards the sea level is called as katabatic wind. So from valley to tip of mountain, valley wind, and from tip of mountain to the valley it is called mountain wind, and from the high plateau it is katabatic wind, right? Okay, then we have this one more concept of the wind from the oceans. So wind which moves over the ocean, it descends, it gets ascended over a mountains. So for example, your monsoons itself. So it will be moving over Indian Ocean. Suddenly it finds the Western Ghats. When it finds the Western Ghats, it has to go upper. It has to go upper. So what happens? See, when it is moving over the ocean, the wind will be having lot of moisture. What is moisture? It is the water content in the air. So over the oceans, it will be having lot of moisture, and when it moves up the mountain, right? When it moves up the mountain, the pressure will get increased. Why? See, it is moving at the ocean level, there is high moisture. So moisture is required for rainfall, right? So here at the base level, the temperature will be high and the pressure will be low. But when the air moves up the mountain, what happens? The temperature reduces. When the temperature reduces, pressure increases. When the pressure increases, there will be condensation. So condensation means because of condensation, the rainfall will happen. So low pressure wind, when it goes up to the hill, the pressure increases. Due to pressure increase, there will be condensation. So this is on the leeward side of this side where the wind comes and goes up the mountain is called as leeward side. The opposite side is called as windward side. So here the pressure increases and it will be rainfall in this region towards this mountain. So but once all the rain goes off here, falls here, the wind will become drier. Means there will be no moisture. Once it goes top to the top of the mountain, all the air, all the moisture will condense and fall as rainfall. So here, by the time it reaches, due to rainfall, there will be no moisture and it has to descend. Once it goes up, it has to come down. When it is coming down, it is a warm air. It doesn't have moisture. Also from high pressure, tip of the mountain towards bottom, towards low pressure. So it is moving. So it is getting lighter and lighter. And also there is no moisture. That is why this side, there is no rainfall. Windward side, there is no rainfall because of low pressure, low moisture, and also increasing temperature. By the time it comes down, here it will be, the temperature of the wind will be high. By the time it comes down, it will be low, because of which the rainfall on the windward side will be very less, right? This is the concept of the mountain side or the leeward side of the rainfall and also windward side of the rainfall, right? Okay, so when it is coming down, when I told you it gets heated up, this air at the top of the mountain, it will be having high pressure, low temperature and also high density. By the time it comes down, because of here what will happen? The temperature increases and pressure will get, so when temperature increases, pressure will it is inversely proportional, so it has to reduce. So what happens? It gets heated up. When the wind gets heated up, the eating up of the wind down the slope of the mountain is called as adiabatic process. So adiabatic process, because of, see, adiabatic process, it is a process in science, in the geography. So where there is a change in temperature without addition of heat. Adiabatic process means that the temperature of the air will change, but there is no addition of heat. No external heat is given to that body. So due to adiabatic process, the wind gets heated up. When it gets heated up, here if there is any snow, that snow will be melted. So this is actually imported in the North American region. In the North American region, what happens? There is one wind called Chinook. So this Chinook, it comes down from the Rocky Mountains. Rocky Mountains on the western coast of the America. So from the ocean, from the Pacific Ocean, it comes, it rises up the Rocky Mountain. The rainfall will fall on its side. Here it will be dry, and by the time it gets down, it will get warmer. Here North America is full of snow at that time. it will melt all the snow in the North America, the Chinook. So this is the wind called Chinook. This is the adiabatic process on the leeward or the windward side of the mountain. Okay. So actually this is windward side. This is leeward side. I got confused. So this is, so wind is coming from this side, right? So this is windward side, from where the wind comes. Whereas this is leeward side, where the wind goes down, right? Next, we have the concept of air mass. Concept of air mass. What is air mass? So, when the air is over a particular region, if the air is over this region, it acquires the properties of that particular region. What properties? It will acquire the property of temperature. It will, so suppose air is in this room. So the temperature of this room, the humidity of this room, the density, the pressure of this room, everything will, every quality of this room will be captured by the air in this particular room. That is the same way the air over a homogeneous area, over a very vast area, suppose a desert or a mountain, right? So over long time, so if the air is present in that particular area over a long time, the character of the area will be acquired by the air. So that particular, because of the acquisition of the particular character, the air will become a certain mass. The certain quantity of air will have with certain specific characteristics, that is called as air mass. So and the region from where the air acquires the characteristics is called as source region. For example, this room, the air is acquiring the characteristics means this room is called as the source region. So what are the different source regions we have? We have oceans. So air might acquire the quality of oceans, it might acquire the quality of continents and also polar regions and also deserts. So these are the various areas where the air can acquire the characteristics. Okay. So this air mass has a distinctive character. It has a character of what? I told you, temperature, pressure, humidity, right? So there are 5 types of air mass. Totally there are 5 types of air mass. What are they? The first type of air mass is maritime tropical. Maritime, what is maritime? Tropical. Tropical means it is in the tropic region, and maritime means it is over the oceans. So in the tropic region, over the ocean, the air mass is called as maritime tropical. Then you have the second one, continental tropical. What is tropical? In the tropical region over the continent, it is continental tropical. That is the second type. Third, you have the maritime polar. That is in the polar region over the oceans. That is maritime polar. Then you have continental polar. Continental polar means in the polar region over the continents. That is continental polar. Then you have continental Arctic. Continental Arctic, in the Arctic region. So these are the 5 types of air mass that is present over the earth, right? So this is the concept of air mass. Next we will discuss. So air mass, right, just means the air acquiring the quality of the character of the particular region, right? So next you have the concept of fronts. Not friends, but fronts. F-R-O-N-T-S. So what is a front? Okay. So I told you air masses. We spoke about air masses. So when 2 different air masses, they come and meet. So we might have some cold air mass and some other air mass which has a warm temperature. And these 2 come and meet. So that boundary region, the meeting point is called as a front. So, right? So the meeting point of the 2 different type of air masses, right? So there are various types of front. So what are the various types? First is a cold front. Cold front. So what is cold front means? See, cold air moving towards the warm air constitutes the front called as cold front, right? So next is you have the warm front. What is warm front? Warm air moving towards the cold air. It is called as warm front. cold air moving towards warm air is warm front. Cold air moving towards warm air is cold front, and warm air moving towards cold air is warm front, right? So in warm front, these are the two diagrams. Then you have one more front called as stationary front. Stationary front andre both the airs are not moving, just they are located next to each other. That is stationary front. Then you have the fourth type of front called as occluded front. Occluded front means, see, this is a occluded front. That is cold air moves towards the warm air. And what happens, since cold air is high pressure and warm air is low pressure, so it moves towards a warm air and it lifts the warm air completely from the ground. Or at the surface level, if there is warm air, that warm air is completely lifted up and the cold air will take the bottom region. That is called as occluded front, right? These are the four types of fronts. So these fronts are actually witnessed in the middle latitudes. Middle latitudes means that is between 30 degree and 60 degree north and south. These fronts are witnessed, and in these fronts there is steep gradients. Steep gradients means the change of pressure, the change of temperature and pressure between this region and this region is very high, right? Here also the change of temperature and pressure is very high. So that is why it is called as what? The front, right? In the fronts there is a steep gradient of temperature and pressure, and I told you here it will lift the warm air up. So when the warm air goes up, what happens? It condenses and gives the rainfall. So this type of rainfall is called as frontal rainfall, right? Frontal rainfall. Next, we will discuss the concept of extratropical cyclones, which is linked to the frontal system. So these extratropical cyclones, extratropical means what? That cyclone which is outside the tropic region. Till what the tropic region is there? Till 23.5 degree north and south tropic region is there. Outside this region, whatever the tropic cyclones that happen, those are called as extratropical cyclones. So this we will see at this type of cyclones we see at the mid and high latitudes. Mid latitudes andre above Tropic of Cancer and up to the polar zone and North Pole, and from the Tropic of Capricorn up to the South Pole we see this type of cyclones, extratropical cyclones. These extratropical cyclones are only formed because of the fronts. Tropical cyclones are not formed because of fronts. Extratropical cyclones are formed because of the frontal system. Very, very important, front. Okay. So, how does the extratropical cyclone form? So, I told you it is because of the front passage. So, first what will happen? There will be a polar front. Polar front andre, that is cold air moving towards the polar front means it is cold air. Polar andre cold alla. So, from cold air will be moving towards the warm air. So, that is a polar front. So, initially it will be stationary. It will be a stationary front. There won't be any movement initially. What happens later? Later what happens? This will actually happen in the northern hemisphere. So what happens? Warm air from the south will move towards the north, and from the cold air from the north moves towards the south. So what happens when this movement takes place? See, when is the cyclone from? When there is low pressure. So what is the direction of cyclone in the northern hemisphere? It is anti-clockwise. So here see, this air is moving from the north and warm air is moving from the south. So they will find a low pressure region in the middle, and this air will go around this, and this will go around this low pressure area, and the warm air will go around the low pressure area. So this will form a anti-clockwise direction. So the air will come from here, from the top and the bottom. They will find a low pressure area. So it circulates this low pressure area. This warm air will also circulate that low pressure area. So it will lead to what? It will lead to the extratropical cyclone. So at the front there is low pressure, cold air comes, warm air comes from here, they will find this cold pressure area, so this will circulate this will circulate this, and there will be anti-clockwise cyclone. Cyclone will be formed across the front, right? Okay, so the warm air will go towards the north and south air will come, the warm air will go towards the north and the cold air will come towards the south, and there will be a cyclone, right? Extratropical cyclone. Okay. So this extratropical cyclone is formed only because of the warm and cold front. There will be a frontal system, warm front and cold front. That is why the extratropical cyclones are formed, right? So what happens here, when this cold air comes from the north, and let's say this is the cold air coming from the north and warm air coming from the equator. So this cold air, this warm air will go above this. Why? Because warm air has low pressure, cold air has high pressure. So when it is high pressure means what? It will go down. Warm air with low pressure, it will go up. So this gliding will happen. Gliding will happen and they will start rotating. This will rotate like this and this will rotate like this. So there will be an anticyclone, proper one, right? Okay. So here what happens? This warm air will later on start going upwards because of the low pressure, and it will later on what happens when this entire warm air, so cold air is coming from here and warm air is coming from here, so it will go down. If the entire warm air, this is warm air, this is cold air, if the entire warm air is lifted up, so when it is lifted up, the entire cyclone will dissipate till when there is a continuous supply of cold air and warm air, the cyclone will be rotating. But when the warm air is completely thrown above because of the cold air below, the cyclone will stop, right? Because the low pressure area will be filled by the cold air. So when the low pressure area disappears, the cyclone will also disappear, right? So what is the difference of the extratropical cyclone from the tropical cyclone? One is this happens in the tropical region, that happens in the extratropical region. Second is this extratropical cyclone happens because of a frontal system, whereas tropical cyclones because of a different reason, right? And also the tropical cyclones happen over a very large area, right? So if you see the cyclones in the West Bengal, in the Bay of Bengal, it is over a very large area, right? That is the difference. So tropical cyclones happen over a very large area. So this and also tropical cyclones originate only over the seas. Tropical, the Bay of Bengal, whatever the cyclone happens, it happens only over the oceans, right? Whereas in the extratropical, that is a frontal cyclone, it happens over both the land and seas. Tropical cyclones only over the sea, extratropical both on land and sea, right? And also tropical cyclone, the velocity is very high. The speed of the tropical cyclone is very high and it is destructive. So you have seen what the floods and the cyclones do. It is very, very destructive. And also tropical cyclones move from the east to west. So you see in the West Bengal, cyclones move from east to west, whereas the extratropical cyclones move from west to east in the opposite direction, right? Okay. So these tropical cyclones, they are very violent storms, whereas extratropical, they are not violent. So they are originated over the oceans. Tropical cyclone uttade oceans mele. Then there will be very high rainfall because of the tropical reasons. That is not the case with the extratropical cyclones. So this we will look at the nomenclature of cyclones. So the cyclone, the term cyclone is only used in the Indian Ocean, whereas the same cyclone, if it happens in the Atlantic region, where is Atlantic? Between America and Europe. If it happens there, it is called as what? Hurricane. Cyclone is called as hurricane in the Atlantic region. If it happens in the Pacific Ocean, if it happens in the Pacific Ocean, it is called as typhoon. Western Pacific, China, Japan, if it happens, it is called as typhoon. If it happens over Australia, it is called as Willy Willy, right? Willy Willy, right? Okay. So what are the conditions for the cyclones to happen? First, there should be a very large sea surface. Big sea surface should be there for the cyclones to happen, and there should be high temperature. Temperature over 27 degrees should be there for the cyclones to originate. Next, there should be Coriolis force. Coriolis force idrene cyclones will start, or else cyclones will not start, right? Then there should be no vertical wind speed variation. That is, if the wind speed at the lower level is let's say 10 km per hour, at the upper level also it should be 10 km per hour, right? So if this will lead to formation of cyclone. If the wind speeds are different, then there is no formation of cyclone, right? Wind speed variation should not be there, and there should be a low pressure area. So only when there is a low pressure area, there is a scope for cyclone. Why low pressure area? Because around the low pressure area only cyclone will form, right? So these are the conditions for cyclone to happen. Then, so where does the cyclones gets the energy from? Cyclones get where does it derive its energy from? So it derives the energy from the condensation process. Condensation process means what? The air goes up and gets converted into clouds and precipitation as rain. So the energy for cyclones comes from the condensation process. So, and also the energy comes from the moisture. Moisture, see, because if there is a moisture on the sea, then only condensation. So the air can take up the moisture, go up, form clouds and precipitate. So moisture and the condensation, these are the two processes which give energy to the cyclone. So what are the clouds that are formed in the cyclone, Andre? It is the cumulonimbus clouds. Cumulonimbus clouds. I will discuss what is cumulonimbus clouds. So cyclonally, there is a spirally circulating wind around a eye. So this is the diagram of a cyclone. So see, this is a cyclone proper. Here there is, see, cumulonimbus clouds are there. Cumulonimbus clouds are here. They are coming out of the, see, this is the outflow. This is the eye. Eye andre, it is a region. So I told you, in the cyclone at the middle, what will be there? A low pressure area will be there. That low pressure area is called as the eye of the cyclone. So this is the eye. So when there is low pressure, what happens? The air rises or comes down. At the bottom, if there is low pressure, the air will come down. So here the air is coming down. Whereas in the eye, in the high region, that is around the eye, there is high pressure area. Center low pressure, around it is high pressure. So when there is high pressure, the air will go up. The air will go up. So that is why here it is just like rotating like this, right? So it is, the air is going up around, whereas in the middle it is, the pressure is very low. High pressure, low pressure, and out of which you have cumulonimbus clouds coming out of the storm. So this is the diagram of the cyclone. So vertical section, right? Okay. So this, what will be the diameter of the cyclone? Diameter. So it might go up to 250 kilometers. So one cyclone can be as big as 250 kilometers, right? So this this I region is a very calm region. So you see, whenever there is a cyclone, there is lot of storm, high speed winds, but that is only in the circulating region. Whereas in the I region, there will be no storms. It is very calm area. That is why what happens when the cyclone comes on the land. First, there will be lot of devastation. Why? Because this region enters first. Later, for a brief period, there will be very calm. There will be nothing. Why? The I will enter. But you should not go out just because it has turned calm. Again, the second boundary will come in. So there will be again stormliness. So this is the concept of the eye and eye wall around the cyclone. So here the air will be going up. Here it will be coming down around the boundary, right? In this eye wall, there will be very maximum speed of wind. Wind here it is not flowing. Here it will be at maximum speed. All the rain will also takes place in the eye wall region, right? So this is the concept of cyclone. Next we will discuss thunder and thunderstorms. So what is a thunder? Thunderstorms. Thunderstorms means lightning and thunder. Lightning and thunder. So this is if cyclone happens over a very large area, whereas thunder and thunderstorms happen over a very small area, right? So, but they happen very violently. They are violent than the cyclones, thunderstorms. Sidlu male anta helallanappa adu. So it is this happens cyclones happens over 2-3 days, whereas thunderstorms short duration, right? Very short duration. Why does this thunderstorm take place? Because there will be very strong convectional rain. So there will be lot of evaporation. Convection will be very strong, because of which convection, that is the air going from surface to the upper atmosphere, there will be high convection and the rainfall will be high. So there will be high intensity of convection. So what are the clouds in thunderstorms? Again it is the cumulonimbus clouds. Cumulonimbus clouds, there will be lot of lightning and thunder. Lightning, gudugu, sidilu, male irtade. So also there will be hailstorm. What is hailstorm? Alikallu male. So alikallu male because of the thunderstorms and tornadoes. So this when thunderstorm happens, that is thunder with rain happens when there is moisture, proper moisture. But if there is no moisture at all, where does the rain come from? There will be no rain. So what happens? Then there will be dust storm. So you would be seeing dust will be rotating at some places. So that is also a thunderstorm, but there is no moisture in that. If there is moisture, it would have been raining, right? Next. So here what happens in the thunderstorm? There will be intense updraft of the rising warm air. See what happens? The warm air will be rising, right? So I told you, when there is intense convectional rainfall, normal convectional rainfall would not lead to thunderstorms. When there is intense, very strong convectional rainfall, convection, what happens? The warm air will be rising a lot from the bottom to top. Then only you will get the tropical thunderstorms. Thunderstorms will happen during that time. Okay. So next you have this. This thunderstorm, if the diameter is less, if it gets converted into tornado, it will then get converted into a tornado. Tornado means it's just like this. It will be rotating like this, no? Rotation. So the thunderstorm getting intensified, a stronger form of thunderstorm is a tornado. So tornadoes are generally not witnessed in India. We witness just cyclones. Tornadoes are heavily witnessed in the American region. So there are many levels of tornado: F1, F2, F3, F4, F5. F5 is the strongest form of tornado. So it will be a rotating air, right? Okay. So there will be intense updraft when the air goes up and it gets condensation, and when it condenses, it comes down as a rain, right? That is a thunderstorm, and these tornadoes are also called as spiraling winds. See, winds will be spiraling. So here also at the center there will be low pressure. At the center there will be low pressure in the tornadoes. They are very, very destructive. They will spoil the houses. They will kill people, right? So this is called as tornado. If the same, just like how the cyclones or the thunderstorms, if it happens, so where the moisture is not there, it is what? Dry winds. Dry winds. Whereas if a tornado happens over, see, tornado happens over the land. If the same tornado happens over the sea, what happens? The water will be rotating like this over the sea. Those are called as water spouts. Tornado happening over the sea is called as water spouts. Okay, so this is a chapter on cyclones and the general circulation of air. Next we will move towards the water in the atmosphere. So atmosphere and water. Till now we spoke about the winds. Now we will talk about the water and atmosphere. So in the atmosphere, water will be in what form? In how many forms? It will be in gaseous form, liquid form, and solid form. Gaseous is water vapor, so liquid is rain, solid is snow. So how does the gaseous form is water vapor? How does the gaseous water vapor is formed? It is formed because of evaporation. Evaporation because of the heat. Also it is formed because of transpiration. What is transpiration? The plants and trees, they are giving out the moisture from the leaves. That is transpiration. They are taking the water from the soil and releasing it in the atmosphere. That is transpiration, right? So these are the two forms of the water in the atmosphere. So this water in the atmosphere will be from 0 to 4%. Water content of the atmosphere will be up to 4%. It cannot exceed that. So this water content in the atmosphere is called as what? It is called as humidity. Moisture in the atmosphere is called as humidity. So first we have the concept of absolute humidity. What is absolute humidity? So absolute humidity means actual amount of water vapor. See, if we consider this room itself, what is the amount of water vapor that is present in this room? That is actual humidity, right? Then you have the, so what, how does it, how does the humidity change? So it changes with the temperature, right? So humidity can also be called as the ability of the atmosphere, ability of the air to hold water vapor. So let's say here there is lot of air. How much water can it hold? Right? If the water holding capacity is high, right? That means high humidity. If the water capacity low, it is low humidity. This humidity is dependent on the temperature. If there is no more temperature, the air can hold more water, right? More evaporation. High temperature, more evaporation, more water in the air. That is why in the ocean, in the seashore, all these Mumbai, Kerala, Chennai, if you go, you will find sticky. Your skin will feel sticky, right? Because of the water, moisture in the atmosphere, right? So because the salt moisture, right? Then you have the concept of relative humidity. What is relative humidity? Percentage of water present compared to full capacity. Let's say this room, the air in this room can hold 100 liters of water vapor, but it is holding just 30 liters as of now. So the percentage of water present compared to full capacity, it can hold 100 liters, but presently it is holding just 30 liters. So this is called as relative humidity. How much? The percentage of water present compared to full capacity is called as relative humidity. This relative humidity is also dependent on temperature. It changes with the temperature, right? This relative humidity is greater over the oceans. Why it is greater over the oceans? Because in the oceans there is lot of water available, right? So relative humidity is always high over the oceans, less over the lands. So I told you this next concept is saturation. So this I told you this room can hold 100 liters of water. Suppose if it holds the complete 100 liters, then it is called the water is saturated. The air is saturated with water, right? There is one more concept related to saturation. So at what temperature does the saturation happen? Does it happen at 25 degree? Does it happen at 35 degree? The temperature at which the saturation takes place is called as dew point. It is called as dew point. The temperature at which the air is saturated is called as dew point. Okay. Next, we will talk about the concept of evaporation and condensation. Evaporation and condensation. What is evaporation? What is condensation? Okay. So you know what is evaporation? The water getting converted into gaseous state is evaporation, right? So why does the water get converted? Because of the application of heat. As simple as that. So this at what temperature does the evaporation takes place? So the temperature at which the evaporation takes place is called as latent heat of vaporization. The temperature, ಯಾವ ಒಂದು ಉಷ್ಣಾಂಶದಲ್ಲಿ the evaporation takes place, that is called as latent heat. The amount of heat required for the evaporation to take place, that latent heat of vaporization. So with temperature increases, evaporation increases, right? If the because when temperature increases, the air can absorb more moisture. So that is one thing. But in the air itself, if the moisture is low, then also when the air itself contains less moisture, then also the evaporation increases, because there is more scope for adding moisture, right? So these two areas moisture will increase. So also if the air is moving a lot, if there is lot of wind, high speed wind, then also evaporation increases. These are the three conditions for the evaporations to increase. So this when this is evaporation. So the opposite is from water vapor to water. It is called as condensation. I have already discussed it. So why does the application of heat, evaporation happens. Condensation, removal of heat. If the air loses the heat, condensation will take place. So why does the condensation take place? See, if the capacity of the water to hold vapor increases, evaporation increases. The capacity of the water to hold air decreases, condensation takes place. Exactly the opposite. So the air cannot hold the vapor anymore. So then it will condense and come down as a rainfall, right? So liquid to gaseous state direct is evaporation, whereas this directly, so the liquid getting directly into solid, gaseous to liquid is called as condensation. But if the water vapor directly get converted into solid, it is called as what? Sublimation. Water vapor directly getting converted into solid is sublimation. from gas to liquid, it is called as condensation, right? This is very, very important. Okay. So on which, see, for the condensation to happen, what happens? There should be some base for the condensation to happen. See, if the liquid will be in a vessel or some ocean, right? But if you apply the heat, it will come to the air as water vapor. It need not have any material for it to go and sit. It will be roaming around in the air. But when it gets condensed from the water vapor to clouds, it needs some material to go and sit. So this is called as hygroscopic nuclei, over which the condensation takes place. On which material the condensation takes place, it is called as hygroscopic condensation nuclei. So it is the cooling around small particles. The condensation taking place around small particles is called as hygroscopic nuclei. What are the small particles? It might be dust, it might be smoke, or it might be small salt particles, right? These are the hygroscopic nuclei. So when does the condensation take place? So I told you when the moisture, so there are three areas. One, see, when the air doesn't have any more capacity to hold the moisture, then condensation takes place. That is one. Second is temperature is reduced to dew point. When the temperature, so temperature jasti adre, I told you evaporation increases. But temperature reduced, when you reduce the temperature, what happens? It cannot hold. So instead of evaporation, condensation takes place. So temperature decreased to dew point. I told you what is dew point. So that is the second condition. Third is both the volume and temperature are reduced. Volume of the air. So this is the volume of the room. You compress the room. What happens? Pressure increases and condensation takes place. So air gets condensed. So water vapor will condense. Third condition, and also reduction of temperature. So you reduce the temperature, what happens? The gas will get converted into liquid. So that is one thing. Then moisture is added to air. So already there is moisture in the air. So you add some, so it is saturated. You add some more moisture to the air. What happens? It has reached saturation, dew point. So you add more moisture, what happens? The dew point is breached. So then also condensation takes place. You are adding more moisture to the air mass. So then also condensation takes place. So in what varieties, so these are the conditions for the condensation to take place. So in what varieties does the condensation takes place? So first is dew. What are the forms? First is dew. Dew means water droplets on solid surfaces. So in the early morning, if you see the leaves, grasses, so there will be some small drops of water on the leaves and grasses, right? So that small drops is called as the dews. So it is because of the condensation that happens, because of the condensation. So what is the condition for dew to take place? One, there should be clear sky. Sky should be clear. Humidity should be high. That is, water content should be high. Then air should be calm. So these are the three conditions for the dew to form. So, and also for the dew to form, there is one more condition. The dew point. Dew point andre where the condensation takes place. That point should be above freezing point. What is freezing point? 0 degree. So dew point is above freezing point, then only dew forms. Next is frost. Next form of condensation is frost. So what is frost? The condensation taking place below dew point, below freezing point. And the condensation, if it happens below 0 degree, above 0 degree, dew, below 0 degree, frost, right? So condensation happening below the freezing point is frost. So here what will you see? You see minute ice crystals. minute ice, there will be water droplets here, minute ice crystals will be deposited. So the same conditions, there should be clear sky, there should be no more calm air, and also there should be high humidity, right? Third is fog and mist. So third type of condensation is fog and mist. So when does I told you, condensation takes place when the temperature reduces. So temperature increases, evaporation increases. Temperature decreases, condensation increases. So when the temperature falls, see, when the temperature falls, condensation has to happen. But when the temperature falls suddenly, when the temperature falls off suddenly, then fog and mist will take place. When the temperature is reduced suddenly. So this condensation, fog and mist, happens over fine particles or fine dust particles, hygroscopic nuclei. Fog and mist always happen over the hygroscopic nuclei or dust particles. Fog and mist. So this in the fog and mist, how does it look? It looks like a cloud over the ground. So you go to hill stations, you will feel like cloud is over the ground, right? That is actually fog and mist. So it is like a cloud with base close to the ground. In those places, you cannot see what is in front of you, right? That is why driving in the cloud and mist is very, very dangerous, right? That is why you have fog and mist. So that is why you have fog lamps in the car, right? Then there will be visibility. Visibility will be very poor, right, in the fog and mist. So there is one more concept called smog. So if the fog, whatever I told you, fog, condensation over the nuclei, if it mixes with the smoke, smoke plus fog is called smog. Smoke from burning fossil fuel or wood, right? So then then there is a question of what is the difference between mist and fog. So mist contains higher moisture. Mist is containing higher moisture. Fog is containing lower moisture. That is the difference between fog and mist. Higher moisture and lower moisture, right? So when does the fog is formed? So I told you what is the difference between fog and mist. So fog, when does the fog is formed? So fog is formed when the warm air current comes in contact with the cold air current. If there is a warm air current, warm air is there, that comes in contact with the cold air, then fog is formed. Clear? Okay. So these fogs are mini clouds. They are mini clouds. Okay. Then you have we will discuss about the clouds. So now we will discuss about the clouds. So what are clouds? First of all, what is the definition of clouds? So these clouds are mass of minute water droplets. They are minute water droplets will be there. They are the mass of a minute water droplets in the air. Water droplets in the air is called as clouds. So this is because of the condensation. Condensation happens in the, see, condensation happens over the surface. You will get dew, you will get frost, you will get this smoke and fog and mist. If it happens in the air, free air, it is called as clouds. Clear? So condensation of water vapor in the free air is called as clouds. So this happens at a elevation. So fog mist happens at the ground, this happens at a elevation. So there are many types of clouds. So what are the multiple types of clouds? You have first is cirrus cloud. Cirrus cloud. What is cirrus cloud? This is a high altitude cloud. So cirrus clouds is a high altitude in the range of 8 to 12 kilometers from the ground. So these are thin. These cirrus clouds are very, very thin. And they are detached. These clouds are not attached to each other. And then they are featherly. So they just look like bird's feather. So if you look at the clouds, some clouds will be feather-like appearance. Right? Featherly. So they are thin, they are featherly, and they are detached. So this is a cirrus cloud. So they are white in color. Cirrus clouds are white in color. Next you have cumulus clouds. What is cumulus clouds? This looks like a cotton wool. You know, right? Cotton. So cumulus clouds look like a cotton wool. This is between 4 kilometer and 7 kilometer. This is the middle height clouds. So they are found in patches. See, cirrus clouds are detached. They are not attached to each other. Whereas these are attached. They are found in patches. Some small patches they are found. And they have low base. Flat base will be there. So the cirrus clouds have feather-like appearance. So bird feather-like appearance. Whereas the cumulus clouds have a flat base. Like one proper, you draw the diagram, right, in the schools and colleges about the cloud. So this is the cumulus cloud with a flat base. Whereas cirrus clouds are just like this. So this is a proper cumulus cloud. So then you have stratus cloud. What is a stratus cloud? They are layered clouds. They are in different layers, multiple layers they are formed. They are stratus clouds. They are large in number. Stratus clouds are the highest in number. So these stratus clouds, why are they formed? Due to loss of heat. So definitely clouds are formed because of loss of heat. Condensation means what? Loss of heat. So this, when the excess loss of heat happens, you find the stratus clouds. Then you have the last type of clouds, nimbus clouds. These are very important. These are rain bearing clouds. Rain will always come from the nimbus clouds. So this is black or dark grey in color. You see the black color cloud or the dark cloud, it is a nimbus cloud, right? Okay, so this is actually what is the height of this cloud? It is actually near to the surface of Earth or at the middle latitude. It is either at the middle latitude or close to the Earth, right? So they do not allow sun rays. So if you see the black clouds, can you see the sun outside the clouds or outside the black clouds? No, right? So they do not allow the sun rays to come, sun rays to pass through the clouds. So these are low clouds. Okay, they are near to the surface. They are called as low clouds. Nimbus clouds are low clouds. So they are shapeless. These black clouds, just like this, just like cumulus clouds, they do not have any shape. So these are called as shapeless clouds, and they are thick water vapor will be there. So these are the rain bearing clouds. So next you have the combination. See these nimbus, stratus, cumulus, cirrus. So you cannot find it exclusively. You always find it in combination with one another. What are the combination at the high? So there are 3 levels of clouds. Sorry, 4 levels. So first is high clouds. What are the high clouds? So cirrus cloud is a high cloud. And cirrus cloud combined with stratus cloud, cirrostratus, that is also a high cloud. Cirrus cloud combined with the cumulus cloud, that is this cloud, that is also a high cloud. So whenever you find the term cirrus, just remember it is a high cloud. Then you have a middle cloud. What is middle cloud? Stratus I told you, stratus is a middle cloud. So altostratus and altocumulus. Stratus I told you, layer cloud. So altostratus and altocumulus, these are middle clouds. Whenever you see the word alto, you just remember it is a middle cloud, middle level cloud. Then you have low clouds. What are the low clouds? So stratocumulus and nimbostratus. Stratocumulus and nimbostratus. So these are the low level clouds. So there is no strategy to remember this. So just by heart this stratocumulus, that is stratus clouds combined with cumulus clouds. That is a low cloud, and also nimbus clouds combined with the stratus cloud. That is also a low cloud, right? Then you have the last type of cloud, extensive vertical clouds. That is They are neither middle nor high nor low. They are having they are spread over all these layers. What are they? Cumulus and cumulonimbus clouds. Cumulus and cumulonimbus clouds are the extensive vertical clouds. So whenever you see the word cumulo, you can link it with extensive vertical clouds, but there is no standard formula this. So cumulo and cumulonimbus are the extensive vertical clouds, right? So let us pass the class here, and tomorrow we will take up the certain other features of the word physical geography. So if you have any doubts, any feedback to be given, please put it in the comment section, or join our Telegram channel VHS Education Forum for any further assistance you need towards preparing for any competitive exams. So please make good use of the classes, study well, please take care of your health. Jai Hind, Namaste.